Check, check, check one. What? All right, factoring. Overview on factoring from Algebra 1. Three main types of factoring that you're going to encounter in this review for the most part. 1, greatest common factors. How do you factor the greatest common factor? What does your polynomial have in common between each of the terms that are in it? What can we divide out? 2, difference of two squares. Binomials, perfect squares, together with a minus sign. And thirdly, reverse FOIL. Trinomial, three terms. How can you break that back into two binomials? So that's what we're going to take a look at here in our little factoring screencast. So to start off, GCF, always look for a common factor in every term of your polynomial. Okay, when you factor that out, your answer should look a lot like the distributive property. For example, if we've got something as simple as this, 3x plus 12. GCF, greatest common factor, you've got the 3, you've got the 12, so those are both divisible by 3. So here my greatest common factor is 3. Well, what's left over once I divide that out? Well, that gives me x plus 12 divided by 3 is 4. And so there's my answer. That is the factored form of 3x plus 12. All right. Well, greatest common factors don't always have to be numbers. Sometimes they can be variables. For example, if I have x squared y minus 2x y to the third. So what do we have in common here? Number-wise, I've got a 1 out in front and a 2 out in front. There's a 1 here. Can't see it because I don't have to write it. Here I've got a 2. Whoop. Here I've got a 2. So in terms of numbers, no greatest common factor. But notice that both terms in my binomial here have an x and a y. So how much x do we have in common? This is x squared. This is x squared. This is x to the first. So the most they have in common is x to the first power. We've got y cubed, so the most they have in common is y to the first power. I can't take y cubed out of y to the first. It doesn't work that way. All right. So xy is what we're factoring out. So if I had x squared and I'm taking out a y or an x, that leaves me with x. If I had y to the first and I'm taking out that y, that's gone. Minus my 2 stays put. I had an x, but I factored it out, so I move on to my y's. Y cubed, I took out a y, that's y squared. And so again, you see your answer looks a lot like the distributive property. If we were to take this xy and multiply it back into each part in my parentheses here, I should get what I started with. So that's a good easy way to check to see if you're factoring things out correctly. Okay, so that's greatest common factor. Difference of two squares. We're going to use this. Ding dong. We're going to use this on binomials that have a minus sign. But here's the key. Both terms of your binomial must be perfect squares. So if I have, for example, if I've got 2x squared minus 10, just because I've got a binomial with a minus sign doesn't mean it's a difference of two squares, because 2 is not a perfect square and then 10 is not a perfect square. Here, this would be my greatest common factor. So what would a difference of two squares look like? Well, it could be something as simple as this: x squared minus 25. X squared is a perfect square because I can break that apart into x and x. 25 is a perfect square because that's just 5 times 5. You've got the minus sign in the middle there. Well, think about what type of numbers multiply to give you a minus or a negative. And that would be one positive and one negative. And so that's how I factor a difference of two squares. Notice that both binomials pretty much look like the same thing. They both have an x, they both have a 5. But the signs are always opposites. One's a plus and one's a minus. That's true for every time you factor a difference of two squares. Let's try another one. Let's look at 4x squared minus 81. Again, you've got a binomial. You see you've got a minus sign, so you should think, this might be a difference of two squares. And in fact, in this case, it is, because I can take the square root of 4, which is 2, and I can put my x with it. So 2x and 2x. Square root of 81, I know that's 9 times 9. And then 1 minus sign and 1 plus sign. Does it matter what order they go in terms of your plus and minus? Nope. If you want to have 2x plus 9 and 2x minus 9 after that, that's fine. Alright. Let's try one more. Let's say you've got 4x squared minus 16. So we can see that we've got a binomial, and we can see that they're both perfect squares. 4 is a perfect square, 16 is a perfect square. X squared obviously is a perfect square because it's got a power of 2. The thing is this. 4 and 16 are both divisible by 4. So we actually have a greatest common factor here first. So we're going to take out that greatest common factor of 4. And that'll leave us with x squared minus 4. But what we're left over with inside of my parentheses here is still a binomial. It still has a minus sign, and both x squared and 4 are perfect squares. So I bring my 4 down, x squared breaks into x and x. 4 is a perfect square because it's 2 times 2. I put my plus sign, I put my minus sign, and so actually here I can factor this out twice. I've got a greatest common factor, I've got a difference of two squares, and so this is, I would say this is completely factored. There's nothing else I can do to factor it down any smaller. Alright, sometimes you get those little combinations of two different types of factoring in one problem. Lastly, you've got reverse FOIL. Many of you are familiar with FOIL when you take your two binomials, and you go first, and you go outer, and you take the two inside terms, and you take the two last terms, and you multiply all those together, and you get, most times, a trinomial. Okay, so reverse FOIL, we're just doing the opposite. We're trying to work back to get into something like this. So we use it on trinomials, and we're going to factor them into two binomials. So for example, if I have x squared plus 7x plus 12, I know I want to try to factor this into two binomials. The first thing I should look for is the greatest common factor. Is there something in all three terms that they have in common? Well, in this case, the answer is no. So I know that I can break x squared into x and x. Look at the sign in front of the 12. It's a plus sign. Whenever that sign in front of the constant is a positive, that says go and look at the middle sign, because that middle sign is going to tell you what symbols you have in your factors. In this case, two positives. So now I need to think about factors of 12 that add up to give me 7. Well, factors of 12. 1 and 12. 2 and 6. 3 and 4. Which factors add up to the 7? Well, that would be the 3 and the 4. And so that ends up being my answer, x plus 3 times x plus 4. We'll wrap this up with two other quick examples. We're getting kind of long here. Let's say we've got x squared minus 6x plus 8. So very similar to the last one. Again, no greatest common factor. X squared breaks into x and x. Again, plus sign in front of the 8 says go to the middle. Both of these will be minus. Factors of 8. 1 and 8, 2 and 4. 2 and 4 gives me 6, x minus 2, x minus 4. But what if the sign in front of that constant is not a positive? What if it's a negative? Let's take a look at x squared minus 2x minus 8. So again, look for greatest common factor. It's not there. X squared breaks into x times x. Minus sign out in front of your constant, well, it takes a positive and a negative to multiply to give you that constant. So I'm looking at factors of 8. 2 and 4, 1 times 8. Which pair of factors where one's a positive and one's a negative gives me the best chance to come out with negative 2? Probably not 1 and 8. 4 and 2 might give me that negative 2. Which one's which? Well, I want the negative with my 2 here, so that means that my bigger factor should be negative and my smaller factor should be positive. How can you check your work? FOIL it back out and see if you get the original problem of x squared minus 2x minus 8. So hopefully that helps you out with your factoring. If you have other questions, let me know. We'll talk it out.